Hey, hi everyone. This is Aditya, and I just want to talk about the topic that basically, first of all, I will give you the context what I'm gonna talk about. Um, there is one topic that I need to present in front of the team in the office today, and the topic is how data transmission happens in over the internet. How how a secure data transmission happens over the internet securely. How the data transmission happens over the internet. How the secure data transmission happens over the internet securely. So um, um, so the topic is how the data transmission happens over the internet securely using HTTPS protocol, which stands for Hypertext Transfer Protocol Secure. Um, okay, so there are some things that I will be covering as part of this topic. First, symmetric or symmetric and asymmetric encryption. Uh, what exactly happens behind the scenes when we hit the URL using HTTPS protocol, and why the security uh, is required. Like there is one TLS, transport layer security certificate come into picture, and why that certificate is required, who generates like how we use the keys, what is the use case of public and private key in the asymmetric encryption, why uh, why this background scenario is required to make travel data over the internet. So these are the points that I will be covering today as part of this topic. I hope you're feeling interested. I hope you all are feeling interested in this topic. So yeah, let's get started. So whenever we hit the URL whenever we hit the URL using HTTPS from the client, either from the browser or from the postman or whatever client it is, doesn't matter. First of all, TCP handshake happens. What TCP stands for, transmission control protocol. It's a protocol to make data travel over the internet securely. TLS handshake. TLS stands for transmission control protocol. It's a standard protocol uh, protocol to make the secure communication happens between client and server. So to make the secure communication happens between the client and the server, so that's how we use this TCP protocol in our system. What exactly happens in this protocol? There is a shortcut that people there is a shortcut of TCP handshake that people remember, which says SYN, SYNAC, and ACK, and the full form for these two flags are: SYN is equal to synchronize, and ACK equal to acknowledge. So uh, so what exactly happens is when like client start the conversation, it sends the request to the server by saying, hey, this is my SYN flag, means I want to connect. Then the server sends two flags, SYN and ACK, by saying, okay, let's connect, let's synchronize, and I acknowledge your request with this flag. Now client also send the acknowledgement flag to the server just to acknowledge this request from just to acknowledge the response from the server, just to acknowledge the response from the server side, just to acknowledge the response from the server side. So yeah, and this is the TCP handshake, right? And while doing TCP handshake, client and server both share client generate a random value, and server also generates the random value and share it with, and both share with each other. And why these randoms are required, I'll talk about it in a while. I will talk about it in a while, but this is the first step while transmitting data securely over the internet. Okay. So once this handshake is done, now server generates a public and corresponding private key, and it also gets the certificate from the authentic certificate authority, and share the public key plus certificate to the client. And why this certificate is required? What if someone attacker was there in between, and sends the malicious malicious public key to the user, to the client, right? So we need to have something to validate if this certificate or this response is coming from the authentic server, and that is why the certificate is required. But again, how client validates that if this certificate is coming from the authentic server or not? And the client do that by with the help using the same authority, same authentic same certificate, authentic certificate authorizer. If they validate it, if they validate that it's a valid certificate, it's fine. Then a client generates a pre-master secret key and encrypt it using the public key and share it with the server, right? And this step ensures that this will only get decrypted by the server only, because the server generated the private and public key both, and the server only have the corresponding private key. So when the server gets this encrypted secret key, it decrypts it using the corresponding private key, and now both have that secret private key, right? Client also have that, and the server also have that. Now we generate a shared symmetric key or the session key using the hash function. Now they both use the same hash function, and the input for that function is this shared secret key, including the client random and the server random. These randoms make sure that always the session key or symmetric key would be unique. Every time the session key or the symmetric key would be unique. Every time the session key or the symmetric key would be unique, right? And that is why these randoms were required. Okay. So yeah, and this was the part of asymmetric encryption. We're talking about session, so session layer is also covering right, the presentation layer where we do encryption and decryption. This is that layer over here. application layer, presentation layer, and session layer. 3 layers are covered as follows. Now the actual communication happens between the communication happens between client and server with the actual data that we wanted to share. This is the common key that we generated, that both the client and server uses to encrypt or decrypt the data. For example, let's say a client want to send, it's a post request, and client want to send some data, right? So what client will do is client will encrypt that data with this shared key, with this shared symmetric key, and send it to the server. And if we assume that the attacker is between the client and server, and they, even if they get that, they don't have the shared symmetric key, so they cannot decrypt that key. So it's not possible to decrypt that key, and your data will be securely sent to the server. Now server decrypt it using the same shared symmetric key, and again prepare the response for the client, and encrypt it using the same key, and send back to the client, and client also use the same key to decrypt that, right? So this is the this is the end-to-end communication that happens between the client and server. And now I hope we understand how secure communication happens between a client and a server using HTTPS protocol, right? There are some short forms that we are using while explaining it. One TLS handshake, one TCP handshake, transmission control protocol handshake, right? It's a standard protocol to have a secure communication between client and server, which is used for, as we have different protocols, right? We have FTP, file transfer protocol. The same way we have TCP, transmission control protocol. Second is TLS certificate, transport layer security certificate, TLS certificate, right, which stands for transport layer security. So yeah, this is what I have for today, and this is the topic that I'm gonna cover today. I hope it helps. I hope it adds a value to your understanding, and I hope it's easy to digest. I hope it's easy to digest for everyone, and I think that is all. And thank you so much for giving your time, and thank you so much, guys, for giving your time. And thanks a lot. Bye bye.